So next session, I think it will be started.
Ma'am, good
Very
evening,
long.
ma'am. Minimol Korulla, ma'am, good evening. Welcome to our session, to your session actually. So, uh, let me introduce you. Means,
First, you share the.
is it visible?
Yes, yes.
So, Engineer Minimol Korulla is currently head for policy advocacy and strategic initiatives McAfee India. And her education qualification is she did her BTech in civil engineering and then MTech in geotechnical engineering. Then she did MBA from Indian School of Business. Ms. Minimal Karula is heading policy advocacy and initiatives in Makeup in India. I again repeating, she is actually very active in Codal population committee like ISO, BIS, and IRC, and authorized few important guidelines as part of authorizing group. She is a guest faculty of Indian Academy of Highway Engineers and members of, I cannot see my screen. And prior to McAfee, she worked with Mesakan Mumbai, Ketan Consultant Mumbai, Irrigation Department Kerala, and RIT Kerala. Then in February 2001, they joined McAfee, which was a turning point to get engaged to new technology material. In McAfee, currently, her main assignment is to lead strategic initiatives of global company in India, Southeast Asia Pacific region. She got unique opportunities to get involved in challenging projects of nation in domains of slope stabilization, river bank stabilization, ground improvement, and disaster mitigation projects as technical reference point and reviewer from geosynthetics field, where complex geotechnical and hydraulic solution play key role. Ms. Minimol Karula is instrumental in developing few new products and engineering system in field assessing the techno-commercial benefits of such innovative systems in real application area. Her focus is to use local materials in an optimum way in construction, with emphasis on eco-friendliness and carbon footprint reduction. She received many awards and recognition in national and international level for her contribution to innovation, sustainability, and disaster mitigation. In here you can see Professor Dipankar Chaudhary, IIT Mumbai, giving some token of award there. Hello, ma'am. Are you there? Hello.
It's not visible.
Thank you. Thank you. Am I audible?
Yes, you are audible, ma'am.
Yes, ma'am. You are
Can you say
perfectly audible.
which award you got in this picture?
Yeah. No, I'm really impressed how beautifully you presented.
Okay, I'm just, but I'm not finished. I'm not
Yes.
finished.
Oh my God.
So pictorially, you can see how our expert speaker, Korulla ma'am, is involved here and there for sharing her experience and giving expert talks in front of expert gathering and PhD students and faculty members. And in here you can see she is lifetime member of Indian Geotechnical Society, very big thing. And also, even though she is in industry, not in academia, but she is in some kind of way involved in some research. So she has some publication, not that big, because she is in industry. Still, she is having some publication. So, ma'am, you are so great. We are happy to get you. And this slide is talking about other involvement, application of flexible system in geotechnical engineering, maybe a few years back. And this, so we are now welcoming you, ma'am, for session 10. This is your session for sharing your experience and expertise regarding sustainable geotechnical engineering. So, ma'am, you are welcome. Now, platform is yours. So, please, ma'am, you can start. You can share and start.
Thank you. So let me share my screen.
Yes, ma'am.
Is it visible?
Yes, ma'am. It is visible. Just to make it full screen. Yes, full.
And one more thing, madam, if you could hide this in the bottom of this your presentation, there is stop sharing. You need to hide it so that is there any write-up so audience can see that one.
Okay.
Hmm.
So now can I start?
Yes, ma'am. You
Yes,
can
yes,
please.
ma'am.
Okay.
Please, ma'am.
Thank you so much. Uh, I was seeing that I asked Professor, it's a Friday and especially Valentine's Day. So whether somebody will be there in this evening time. And I'm really impressed to see that the participants are there. Of course, Professor Shivakumar Babu's, it was very good basic talk was there. But the questions I was seeing that very relevant and intelligent questions on the geosynthetics applications that has come. So that is showing that it is really the participants are not only there, but they are showing a lot of enthusiasm and interest. So that really encouraging me. So the topic sustainable geotechnical engineering solutions, which is very close to my heart, because the why I am in the present organization for longer period compared to all other organizations I worked. I was teaching in an engineering college. I worked in Kerala irrigation department. I worked with some structural design firms, but in McAfee I am spending a lot of time. One of the reason is the the freedom to work for sustainability and eco-friendly solutions. And the second part, the these type of platforms, a lot of platforms where the two-way learning happens, and we can think together how we can make it the world a more sustainable and more eco-friendly world for our future generations. So the flow of the presentation is some introduction, then ground improvement. Okay. We were listening from Professor Shivkumar Babu, the application of many of these polymeric materials in in landfill, in soil reinforcement, and he mentioned about the ground improvement also. But specifically, I want to give emphasize the ground improvement, how these geosynthetics and related materials can play in coastal roads, marshy areas, and filled up land. Pavement applications. This is a huge application area. The last 5 years, it is really going in a very fantastic way, I will say. One of the reason is one of the code or guideline which is published by IRC. It's IRC SP 59. It is for the payment applications for cost effectiveness and durability. Then slope stability. Slope stability is an area. Definitely, the geosynthetics alone may not work. It may have to combine with the um, other type of materials also, but still it can play a big part. So here I will be introducing, apart from the geosynthetics, I will introduce other geotechnical related materials like steel meshes, steel ropes, energy absorption panels, and then bioengineering materials like coir, jute, and mixed type of products. Then which are the national and international standards? I think Dr. Bhubadi was asking Professor Shivkumar Babu about CRRI has published a document for the where the embankments, the road embankments, where we can use the waste materials. I was also a part of that committee, that H4 committee, and I want to complete what Professor Shivkumar Babu has said. We can use the different type of geosynthetics in with the waste products, but definitely we have to know the plus and minus of the geosynthetics, and we have to know the composition of the waste also. So definitely a procedure has to be adopted, but we can optimize the overall construction cost. We can optimize the material cost. We can increase the durability when we are using these type of products. And now I will say that it's a very encouraging note. The our national standards that is really becoming at par with the international standards. We do have now not only IRC, where CRRA and all are playing a big part, but the Bureau of Indian Standards, which is drafting the codes and guidelines for the all other departments like highways, railways, airports, the landfills, for everyone. The Bureau of Indian Standard also is giving a lot of importance to the innovative products and materials, the whatever it is in use in India, and even the futuristic ideas. At least a state of art is getting formulated. And apart from the Bureau of Indian Standards and the IRC, we are following number of ISO standard. India is a participating member of some of the ISO committees, and those type of guidelines which we can use without any inhibition, those are also, I just want to give a glimpse on that, and some recommendations for the general civil engineers. So I'm sure that as the topic of this series of sessions are sustainability, this must have already discussed. But question is, when we are doing the day-to-day design, are we considering the conditions of today or future? So definitely it should be future. In some of the branches of civil engineering, few of the branches of civil engineering, we always go for the predicted volumes, maybe in hydraulics, maybe in highways, but not in everywhere. And we are not really thinking about the decaying of environment and the increase of the population, the increase of waste volume, and the recently everyone is talking about that climate change. Even fifth standard student also will talk about that. But are we using it when we are going in our regular designs? And what is going to be the condition, whether it will be better than today or worse? It may be in the first class cities, the main areas maybe near the capital city, the main areas may be good and clean, but we know that many parts of even our cities, main cities, are not in a good shape, and it is getting deteriorated. I was for so many years in Delhi, we were staying, and definitely it was a big concern that whenever we are traveling, it was a big concern to see that how the atmosphere is getting polluted, how the water is getting polluted, how the land is getting polluted. So this is, unless we are not taking drastic steps, this is going to further increase only. And are we taking it in all aspects, or only in the landfill design we are thinking about the environmental degradation, or are we considering it in all aspects of construction? And the next is the scarcity of natural resources. In many of the states in India, nowadays, the good sand, our designs are telling, our guidelines are telling, in we have to use frictional free draining sand. But that frictional free draining sand with the classic assumptions, cohesion is equal to 0, angle of internal friction is equal to 30 degree or more than that. In fact, that is not now available in many of the parts of India. Many states in between, the sand mining is completely banned. But are we preparing that what our next generation, with what material they are going to construct, with the same books, same syllabus, with the small modifications? Are they making them prepared? Especially the country like India, where we cannot jump to something so fast because of the economic diversity, the mixture of culture, developed stage. So how much the so where I want to touch, this is a very big topic, and I don't think from my humble session can cover even a part of it. But still, where I want to touch, one is about the frequent natural disasters, earthquakes, landslides, tsunamis, floods. Now, in every year, we are hearing some very bad calamity happens in some part of India. So I am from Kerala. The last year, July 30, very big landslide happened in Wayanad, a part of Kerala. The 10 years before, not 10, 12 years before, Uttarakhand, it's called, if Kerala is known as God's own country, the Uttarakhand is Devabhumi. So that got completely devastated by series of flood-induced landslides. But these are the states where the natural calamities were common for the last so many years. But nowadays, it's repeatedly happening. So how much we engineering fraternity, we are the people who are very close to the nature and communities. So how much we are preparing ourselves, how much we are preparing our new generations. And fast depleting natural resources, I talked about it. Increase in carbon emissions, land acquisition concerns, even Dr. Babu also was mentioning about it. Rapid pace of infrastructure construction. Construction is keep on, especially in the cities. It's getting suffocated by the construction. So the solutions, if we are talking about, see the green solution as far as possible. We cannot completely means prevent the damaging of the ecosystem. When we do a construction, when we bring the development, some change will happen. Some distress will happen for the natural ecological balance. But if we are trying to give the green solutions where we can incorporate the nature friendly materials or nature itself, that can one way the the uh, disaster or the environmental problems which can happen later can be minimized. Local material usage, that is again one of the major contribution. If we can use the local material itself in the construction, that can really a big contribution to sustainability. Lower cost of transportation, reduced carbon footprint, give an importance to carbon footprint reduction. Whenever we construct something, don't think about, okay, let it means let it deteriorate, we can have a maintenance after 4 years. Try to make try to add life cycle cost values, and those analysis has to be focused for low maintenance. And as far as possible, flexible solutions. Why flexible solution? Especially in a place where a lot of disasters can happen. Instead of going for rigid solutions, if we go for flexible solutions, those can accommodate a lot of movements. So the using the flexible solutions, we can reduce many places, the requirement of reinforcement, the requirement of ground improvement, the requirement of too much excavation, we will be able to minimize it. So sustainable solutions, when we are talking, it's not about just a green solution. It should be technically strong. It should be economical. Definitely very important. Then only it will get repeated. It should be environmental friendly. It should have less maintenance, and finally, it should be durable. So the different application areas, I'm basically talking again as a continuation of Dr. Babu's presentation about the flexible type of materials. One major family is the polymeric family. A lot of family members are there. Okay, initially it was mainly geomembrane and geotextile. 20 to 25 years before in India, those were the main material we were talking about. But now they brought all their other relatives also, cousins, aunties, uncles, grandchild, everyone has come in India, and a geosynthetic baby is getting born every day in some part of the globe, because the use is getting increased, and more manufacturers are coming in the field, and they're making a differentiated product so that they can create some new brand there. But if you are classifying the major applications for the polymeric materials or the other flexible materials which I talked about, like bioengineering materials like wire or jute, or maybe the rockfall protection meshes or rockfall barriers. So basically, ground improvement, pavement stabilization. In the pavement, the subgrade stabilization, slope protection and slope stabilization, simple erosion control measures to the complex erosion control or erosion control measures, rockfall mitigation measures, drainage solutions. In each of these, the application, a number of product families are there. For example, rockfall mitigation measures. When I am talking about, I talked about different types of steel meshes can be used where rock can be holded. Then barriers can be used, avalanche protection measures, umbrella systems. So a series of different types of flexible systems are now available in the global market as well as in India. And these are covered in our Indian guidelines also. So definitely this type of the alternate technology as well as the system, its specification, those should be a part of the academic curriculum also. Now, starting with the ground improvement, coastal roads, marshy areas, and filled up land, uh, I have seen Dr. Babu has already covered something, the PVDs, as well as he talked about other ground improvement methods also. So I'm basically talking about the basal reinforcement, okay, where geogrid can be used as a shallow ground improvement method, and it can be combined with the PVDs wherever the clay is there as the main foundation material, or it can be combined with the stone columns also. Okay, so the basal reinforcement and basal reinforcement plus PVD, basal reinforcement plus the stone column, not simple stone column, geosynthetic engaged stone column. So these are the three uh, points I want to cover in the next few slides. So basal reinforcement, I will say this is something which is really a very wonderful material where the geogrid can be used like something like a raft in structural engineering when we are giving the foundation. So raft is where the best thing, objective of giving a raft is where we have to control or where we have to stop the differential settlement, right? Why? Because in the raft, there will be a complete redistribution we are assuming, and we are designing the structure like that. So if we are using a geosynthetic, not any geosynthetic, but a geosynthetic with a reasonably good tensile strength, and the second part, the second property is more important, it is stiffness, a high stiffness, then that can act like a raft, so that whatever the load which is coming, that will get redistributed, and the settlements, especially the differential settlements, will get regulated. If we have to really understand how the inclusion of this geogrid, how it will modify, you may have to do a numerical analysis. But even with the normal calculations for bearing capacity, there also we can take the advantage of the using a geosynthetic. There is a code in IRC 113, the design and construction of the basal reinforced embankments. It is giving the different analysis for 6 type of failure mechanisms when we are using the basal reinforcement. Now, the basal reinforcement can combine with the PVD. In what circumstance we will go with the simple basal reinforcement, and in what situation we will go with the PVD plus basal reinforcement. Simple basal reinforcement, suppose if we have to place a high embankment over a silty sand, phi value maybe phi maybe say more than 20 degree, but the embankment height is more. So in that case, even the embankment construction, if you are doing without a ground improvement, it may get sheared off. So there we can go with a simple basal reinforcement, because the immediate settlements, it will get die out during the construction itself. And if this 20-degree value, if we can get a little jacked up, and if the loads are getting uniformly distributed, then it will be safe. So we can go a basal reinforcement in that case. But suppose we have to construct a high embankment over a clay stratum, and the values of the shear parameters are very poor, like phi is almost zero, cohesion is 10 kPa only, then it means something like the shear strength of our saliva. So in that case, if we are just putting a basal reinforcement over it, we may not be able to really construct an embankment. In that case, we have to first consolidate the clay stratum. So we can go for PVDs, prefabricated vertical drains. So it will accelerate the consolidation. PVD also can be called as a geocomposite. So the PVD will accelerate the consolidation by reducing the drainage path, and the basal reinforcement will help the uniform distribution of the forces, and it will control the differential settlement. The same can be combined with even piled embankments as well as with the geosynthetic encased stone column. So prefabricated vertical drains, basically when we are using the PVD, the current, how much is the time which we can wait? So the end of consolidation, that is the time. Maybe it is 45 days only we can wait. Maybe it is something 6 months we can wait. So that will decide the PVD spacing as well as the diameter of the PVD. But how much height we can construct in one stretch, that will be depending on the shear strength of the soil. But when we are putting a basal reinforcement, we we can at a stretch we can go for more block heights for the embankment construction. So someone who is executing the structures or executing the work in the field can understand how it is significant when we are allowing a stage construction with the permission to go for higher block heights. That will be a big advantage, that will be a big cost reduction for the constructor or the contractor or the end client. But when we are inserting a basal reinforcement like this, so usually when we put a basal reinforcement, it may be required to put anchor blocks at the end, because when we are just placing the geosynthetics and placing soil above it, the geosynthetic may not stretch enough. So these anchor blocks will give good stretching to that, and the forces will get, or the strength will get mobilized. So it's important to give the anchor blocks. And again, a drainage media may have to be provided below the the uh, basal reinforcement, especially when we are placing the basal reinforcement over soft clay. And the different failure mechanisms I mentioned about IRC 113, so which are to be checked. One is the rotational stability of the embankment. So whether basal reinforcement is given or not, if it is a high embankment, one has to check the rotational stability, or Bishop's method or Jimbo's method or whatever it is. But when we are applying a basal reinforcement, the rotational stability analysis will give us the tensile force which may be developed in the basal reinforcement, and hence we can decide the type of geogrid. Why it is important? When the geogrid tensile strength requirement is higher, one has to spend more money. So if we are analyzing, we will be able to optimize it, and hence we can control the cost of the geogrid. Second is sliding stability of embankment fill. So again, the for the basal reinforcement, how much it has to be extended sideways, that will be decided by two checks. One is sliding stability, and second is foundation extrusion stability. And finally, the overall stability. Overall stability is something like rotational stability only. Nowadays, softwares are available. One can do it. The Bishop's and Jembu's method. Only thing for this slip circle, here it is a overall the stability will be checked. But sliding stability and the foundation extrusion stability, those are very, very important to understand how much should be the extent of the geogrid. Okay. So definitely I cannot cover all these failure mechanisms. So if you are interested, one can go to IRC 113. It is a very thin book, and it is talking in a very simple way. Somebody who knows earth pressure theories, they will understand the equations, and even worked out examples and a number of case studies are explained in this particular code. Now about the PVD. Okay. So as I told you that PVD itself is a geocomposite. It will be a combination of a filter jacket and a core. The filter jacket is made of the geotextile or geofabric, and the core is made of a stiff material. So what is the function of the filter jacket? The function of the filter jacket is the same as any filter. It will prevent the soil particles to enter into the core, and it will allow the movement of the water. Whereas what is the function of the core? So first of all, the core will support the filter jacket because it is a fabric. If you are putting in a soil, if it has to stand, then a support is required. So this core is something which is supporting the filter jacket. Second, it will provide the internal flow of the water along the drain. And finally, it will provide the resistance to the longitudinal stretching as well as the buckling of the drain. So this is a project which I was a part of the design team, and even the implementation time, the project was monitored as a part of the expert committee. So I know the project. So here you can see that the different layers of soil which is coming in the foundation. So clay silt, then the clay silt of medium compressibility, clay of high compressibility, then with some clay gravelly sand, then clay with the is having some change. But at the same time, the overall, all these clays are having very poor bearing capacity, and additionally, the settlement characteristics are really very dominant. And this type of a clay, if we are directly placing an embankment of height, say 8 to 10 meter, that will be settling like 1.5 to 2 meter. And especially the cross section what we are seeing here, it is for a bridge approach. So if we allow 1 to 1.5 meter settlement, you can imagine that the to the bridge we may have to go some ladder has to be provided, right? And for the vehicles there will be a lot of problem. So when the for this project, there were two suggestions. One was with the PVD and basal reinforcement, and the other suggestion was with the stone column and not the regular stone column. As I mentioned earlier, it was a geosynthetic encased stone column. So I'm sure at least uh, few of the participants must have heard and maybe having some familiarity with the geosynthetic engaged stone column. So what is it? As I mentioned that this particular area, the clay was very poor. Its phi value was almost zero and C value is only 10 to 15 kPa. So in such a place, if we are driving a stone column, what will happen? The clay will slowly infiltrated to the stone mass, and finally it will be means the behavior will be of the clay only. But if you are putting a filtering geotextile, then definitely that can act as a deterrent for the clay particles to deteriorate the soil mass. So that is the function of the geosynthetic encasement. So the primary function of this type of geosynthetic encased stone column is definitely it is acting like a end bearing pile, but its secondary function is it will act as a drainage media as well as separation and filtration. So the same stretch in some areas, I told you that somewhere it was PVD plus basal reinforcement, but in some stretches the PVD alone will not work, and in those areas, stone column and basal reinforcement, the combination were being used. But in both the cases, the basal reinforcement has played a big part, because if basal reinforcement was not being used, the overall cost of that some 20 kilometer just for ground improvement, it was going something like 200 crore. But with the introduction of the basal reinforcement, that has come down to between 25 crore to 40 crore. So I don't know the exact, the final figure. The when the solution and the installation methodology was finalized, it was 25 crore. But later the contractor told me that no, some increase happened because of some delays and on. So I guess that it may be another 30%. But he also admitted to me overall it was the initial 200 crore has got reduced to 40 crore. Now, let me touch the payment applications. So, the payment application, the first is the geotextile, especially when we are constructing a road embankment over a very poor soil. If we keep a separator layer or a filter layer, then definitely the contaminated area will not damage the pavement layers. Second is the geogrid. I was talking about the basal reinforcement, and I talked that it should be having good strength, good tensile strength, and good stiffness. So you may ask me that, okay, what is the range? So when I am talking about good tensile strength, I mean something which is more than 100 kilonewton per meter, and stiffness more than 1000 kilonewton per meter. But in pavement, we don't record those type of geogrids, which is having more than 100 and all. We can go for even 40 kilonewton per meter or 25 kilonewton per meter. But these type of geogrids, they should possess some specific qualities so that the pavement layers will be stable under traffic load. Okay. because payment layers are something which is very near to the wheel loads, and under the wheel loads, the particle, the base components or sub base component, that should not slip off. So the geogrid should act as something which is increasing the stability. So usually extruded geogrids are being used for this purpose. The third is another geosynthetic material, geocell. It's a honeycomb structure where the aggregates or even concrete or even vegetated soil can be fixed, and it can be used in payments. In payments, we cannot put vegetated soil. When we are using it as erosion control, we can use vegetated soil. Geomembrane, you heard already about its purpose. In landfills, in irrigation canals, we can use geomembranes. Those are impermeable material. Geonet is there. Geomat is there. Geomat is basically for erosion control. So for the payments, as I mentioned, there is a different families of geogrids are there. Knitted geogrids are there. Woven are there. Bonded are there. In that, extruded geogrids are considered to be one of the best for the payment stabilization. Okay. So what is the use? This illustration, I think it will give some idea. When we are using the extruded geogrid, especially in base or sub-base layers, the, the gravel or the aggregates will get interlocked very nicely, and the increased resistance will act against the deformations caused by the wheel loads. So the usually the extruded geogrid, biaxial geogrid, or even the multi-axial geogrids can be used. But in India, at the moment, the biaxial geogrid is the most popular, and they are the basic polymeric material is polypropylene, and it will exhibit high modulus and high tensile strength. And one more important terminology when we are using in pavement application is the junction strength and junction efficiency. So that is also very good for extruded geogrids, and hence extruded geogrids are the best for the pavement applications. So now, what are the mechanisms which will be helping the extruded geogrid to increase the stability and reduce the maintenance requirements for payments? So, as I told you that junction efficiency is one of the most important terminology, and here, if the junction efficiency is good for a geogrid and if it is inserted when traffic load is moving, the whole base or sub base where we are inserting or where we are incorporating this geogrid, that will act as one solid platform which will not move, or where the strains will get controlled. Sorry. And the all type of cracks with of the geosynthetics, especially. So, apart from base reinforcement or sub-base reinforcement, even bituminous layers can be reinforced, or the application of geosynthetics can increase its quality. Like paving fabric, it's a geotextile which can be used in the asphaltic layers. So, it can act as a good moisture retention, and it will be helping for preventing the water intrusion, and hence the payment deterioration
Excuse me. Hello, dear participants. Some of you have not muted yourself. So please mute yourself. And madam, we cannot hear you. Hello. Madam, hello. Please unmute yourself, madam.
Yeah.
Yes.
Can you hear me now?
Ah,
Okay. How much you heard?
actually, we lost him. Yeah.
You were hearing about drainage?
Yeah.
Ma'am, excuse me, ma'am. Please, from previous slide, end of the previous slide, we cannot hear you.
Okay. Have you heard about asphaltic reinforcement?
No, ma'am. Previous one.
Okay. This one?
Yes.
Okay. No, let me say that you didn't miss much. Okay. So I was talking about the extruded geogrids for the pavement stabilization and reinforcement. The extruded geogrid is the best because of its the efficiency, junction efficiency. The under the wheel loads, it will not allow the aggregates to move, and it will control. It will absorb the strains. So because of this, the maintenance time in a payment, that will be drastically, it will increase. For example, if a 20-year design period is given for a designer for a payment, usually he will define after every 4 years, especially state highways or major district roads. He'll tell that every 4 years I need a maintenance. But someone who is designing with the geosynthetic, he can really tell. If he is having the real experience, he can tell that for the 20 years I don't require any maintenance. Okay. Someone who is conservative will tell that, okay, I may be requiring, say, after 9 years. That means only 10th year a maintenance is required. So this will really a very big contribution to the the life cycle cost. But it is not only about the maintenance cost reduction. Even for the material reduction will happen, because if we are going for a flexible payment, the thickness can be reduced by the overall thickness can be reduced by 15 percentage to 25 percentage. And today in our country is doing really kilometers and kilometers of construction, and even 100 thickness reduction is really a big reduction in the overall economy. As well as we know what is being used, the bitumen, the aggregates, everything is really, the big use will end with the depletion of the natural resources. So that may be the reason I can see that the last 5 years, the concept of the carbon footprint that has increased in our country, and many of the projects are now adopting the use of the geogrid as the reinforcement in the, especially in flexible payments, base layer and sub base layer. I won't be able to explain everything, but definitely I will recommend somebody who wants to know more about the application of geosynthetics in payment layers, IRC SP59, like IRC 113 for basal reinforcement, IRC SP59. For both these codes, if you are having any doubt, you can definitely ask me, because I was the subgroup chairperson for both these codes for the authoring subgroup. So now apart from the this base reinforcement, the even the asphaltic layers, because we know base and subbase, it is basically aggregates. Okay. But what is the maximum expensive material in a bituminous payment? The asphaltic layers, right? So even the asphaltic layer thickness can be reduced and increase the durability if we are selecting the appropriate geosynthetics. Like paving fabric is a textile material, a non-woven textile material. So that can act as a moisture retention and separator property. It can give to the asphaltic layers. And paving grid, glass grid, made of glass fibers, those are really, it can increase uh, the the strength of the asphaltic layers, and it can act as a overall a stiffening layer. Then the composite, AIC. AIC means asphalt interlayer composite. It is in fact a combination of the glass grid plus paving fabric. Okay, so you can assume what will be the function. It will do the combined function. It will increase the strength, and at the same time it can act as a moisture retention composite also. So now the one more family member which give a lot of value to the sustainability concept, those are drainage composite. So I'm remembering when I used to go to CRRA and all, few years before, like maybe 10 years before, they used to hear about drainage composite, because I used to explain, see, the drainage composite can replace 600 gravel thickness. Okay, usually when we have to give, suppose behind a retaining wall, we have to give the gravel filter, gravel drain 600 60 centimeter. Okay, so which require big space, which require a lot of aggregates. Okay, but as the alternative, I'm talking about a polymer composite. 10 years before, it had to be imported from Brazil or Malaysia or some other countries. So after hearing me, my friends in the CRRA, they used to tell, okay, fine, madam, very good. It's all very good, but it is good for academic purpose. So we will go with the natural aggregates, but is still available and still cheaper in India. Okay. But the last 5 years situation has completely changed. This is a very hot product because the cost of aggregates has shooted up. Good aggregates we are not getting. So even if the contractor is bringing the aggregate, once the quality test we are doing, it's not having the quality, then it has to be rejected. Whereas the drainage composite, if the quality standards once in the from the factory itself it is controlled and the correct testing procedures are adopted, then once it is coming to the site, you cannot do any type of manipulation there. But at the same time, there are any good material also will get, if it is not being selected in the right way, if it is not being installed in the right way, it can create problem. So the drainage composite, with all the merits I am telling, at present I have seen a number of projects where the selection was not correct and the installation was not correct. It didn't work nicely. But majority of cases, the drainage composite is a very good alternative for the 600 gravel drain. Now, what is the composite? Composite means there will be a drainage core, a most of the time maybe a polypropylene core, which is sandwiched between two geotextiles. Okay, and these two geotextiles, kapda fabric, those will act as filter. So when we are putting horizontally or vertically, the the both sandwiching layers, upper and lower or right and left, will filter the water. Now, before I am stability also. So for slope stability, again, anyone who is, even our the children, they are studying about how the erosion control can be done. The best way is to bring vegetation. Okay, but whether vegetation can come in every slope, that is the question. the vegetation may not come in every slope, especially when the slope is, the angle is more than say 60 degree. Up to that, some part of India, it is easy, like northeastern states, Arunachal, Assam, maybe in Karnataka, Konkan area, Kerala, these places, it can come easily. But in many other states, it may not be easy. But even in some of the Himalayan states where a lot of greenery is there, for example, Himachal Pradesh, we were doing a national highway project. So it is seen that the slopes had to be made near to 60 degree. It's a good soil with cohesion and friction, so it can stand 60 degree. But the way we expected, the vegetation didn't come. So then the question has come, what can be done? Okay, we civil engineers thought that bringing vegetation is so easy. If you are especially in a place where rain rainfall is quite strong, it will be easy. That is our concept. But we learned that the soil's agronomical factors we have to check, especially the pH, the acidity, alkalinity, as well as the different elements like sodium, potassium, whatever it is, it should have a correct proportion. Then only a slope will make the vegetation to come easily and fast way. And especially when the cut slope, when you are cutting a slope in steeper way, this requirement will become more stringent. So then how we can here take the help of the geotextile materials. Okay, so whenever the slope is less than 45, we can go with the coir or jute itself. But when the slope is say between 45 to 55, there we may have to go with the some material which is having some mats which are having some tensile strength. Okay, and if it is more than 55 to 65, the tensile strength may have to be say more than 10. And if it is more than 65, maybe with some cohesion the slope may be standing. But if the erosion need to be stopped, the erosion control mat itself has to have a strength of more than 35 kilonewton per meter. And then it should have a component which is facilitating the growth of vegetation. Finally, the installation should be the friendly, contractor friendly. Otherwise, contractor is not going to adopt. For that, drapability has to be good. Okay, like coir and jute, one advantage is, especially for jute, the drapability is very good, whereas its tensile strength is not so good. So, in many cases, we can combine the bioengineering materials like coir and jute plus the polymeric material which is having the tensile strength also. So, the code or guideline which can help here if you want to know more about the selection of different types of erosion control measures, you can go for IRC 56 and MORTH guidelines. In the highway engineers call it as orange book. And in some cases, after all doing this erosion control measures and all, still the vegetation may not come. In that case, one may have to go for HECP, hydraulically applied erosion control product, like hydroseeding. Here, the seed will be sprayed with a combination of fertilizer, lime, biostimulant, moisture retention polymer, and other uh, elements which can make the soil fertile and the vegetation can come quickly. Now, in the slope stabilization, so apart from the erosion control, we have heard about the reinforcement, especially from Shivkumar sir's presentation. So we may have to combine in many places the reinforcement, erosion control, and nailing techniques. So especially the nailing will be useful where we cannot go for excavation, but at the same time we have to retain. For example, what you are seeing in this picture, this is a real estate project where internal rods require some retention. And here, a combination of whatever you are seeing is a gabion fascia. Gabions are steel mesh wire boxes which can be filled with the stones. But this is not just made of gabion fascia and nailing. There are geogrids which are going inside. So this is the gabion fascia. Can you see the arrow?
Yes, ma'am.
Okay. So geogrids are going inside and it is stabilizing. And you can see the nails and plates at the end. Okay. So this is a combination of different flexible materials together acting as a retention structure. Whereas down below this photograph, here also nails are there. In fact, long nails are there. But in this case, there is no gabion fascia, there is no geogrid. What is the reason? Here, in the upper photograph, there the retention is of a more a weathered rock, whereas the bottom one, it's a rock which is more stable, but at the same time there are some rock detachments. This photograph is of Mumbai Pune Expressway, where in July 15, 2015, because of rockfall, 45 people died at this spot. So here the issue is it is not to make a retaining wall, but to prevent the rock detachment and the accidents due to rockfall. And apart from the nails, there are some meshes. I was talking about steel meshes. So here steel meshes are used as the fascia covering. We call it as drapery system. You know, like sari draping, this mesh can be draped the rock surface. Now, one more is from my state. In fact, not exactly my state. It is in the border of Kerala and Tamil Nadu. Uh, this is a project where L&T constructed. In fact, you may be thinking that it's a 3 meter high slope, but it is much more than that. It is almost 8 meter high slope, and here again it is a soil slope which is cut almost 82-degree. Okay, so nails are going inside, and the front fascia is made of three-dimensional reinforced geomat. 3D geomat is facilitating the vegetation growth. Why 3D geomat? Because it was required to have high strength and at the same time the energy dissipation, because it is a rainfall area. Energy dissipation should be strong, and it is almost 82-degree. If it was a gentle slope, Kerala is rich in coir, it could have been a very cost effective solution, but as the slope is quite steep, L&T had to adopt this 3D geosynthetic mat as per MORTH. So then gabions are steel wire mesh boxes which can be filled with stones, and it can be used as the gravity structures. It can be used as the fascia of reinforced soil structures, but it can be used as simple gravity structures also. And what are the benefits of using these structures? Because those are just wire mesh and filled with the stones, it is completely free draining. The 30 to 40 percentage of voids are there, so the weight will be 30% less than a random double masonry work. Because of the free draining property, pore pressures will not be there. And this woven steel wire mesh, it is a flexible material, so we don't have to worry about the again the settlement, because for the flexible structures the code is permitting high level of settlement, like up to 300 settlement. The structure will not get affected at all. So the flexibility, the free draining property, the density reduction, all these are contributing for the uh, eco-friendly nature as well as the cost effectiveness of the gabion structures. So the gabions are another advantage is the nowadays mechanically woven gabions are mostly in use, and that is supported by the Indian codes. And these gavins can be connected with each other with the lacing wire. You can lace in a pattern which the codes are telling, and once it is done, it will be a complete monolithic structure, and it will be flexible. It can really elongate up to some 10 percentage. It's permeable, so pore pressures will not be there, so the design can be uh, uh, more optimized, and it can be constructed in a very simple way. Like in Mumbai Pune Expressway, whatever the tunnel muck has come from the tunnel construction, whatever it has come, and from the hill cutting, the same stones were being used. You don't have to dress it, you don't have to go for the mortar preparation or anything. You can use even the unskilled and semi-skilled laborers to make it, and those are durable. If a proper designed structure constructed properly, then given structure will stand. Even the first mechanically woven given structure, which is placed 140 years near to a river called Reno, now also it is standing. I have seen it. It's intact. And big trees, if this type of a route is going through a normal stone masonry structure or a concrete structure, a lot of cracks will come. But for a given structure, it will reinforce it. It will become more strong. So reinforced soil structure already Shivkumar Babu sir has told, but I just want to tell that especially in hill roads where I work a lot. So the advantage of going with the reinforced soil structure, it's again the flexibility, it is redistribution of forces. But in the one major difference when we are going for a reinforced soil structure in a urban area as well as a hill road, the major difference is in an urban area, usually we will go for concrete panel or concrete segmental block. But in a hilly area, going with a concrete panel or a segmented block, it will be very difficult. The installation will be very difficult. So in those type of places, we can go with either with the gable fascia, like in this case, this is gable fascia, like steel mesh with stones, or it can be vegetated fascia. Simple wrapping around of steel meshes or geogrid wrapping around, and the geomat or coir mat that can be inserted and vegetation can be grown. But the major element is the reinforcement. Whatever you are seeing which is going across the structure, those are called main reinforcements, and there can be some supplementary secondary reinforcement which will prevent the bulging of the fascia. So I'm little skipping. So the last portion what I want to talk about, it is in fact the rockfall protection. I talked about the Mumbai Pune Expressway where the meshes are protecting the expressway against the rockfall. There are the situations where we cannot make a rock surface, a hill completely get covered by meshes. Like in Himalayan hills, it may be having kilometers of height. There we cannot completely means and say do this type of mesh covering. There we can go for barriers. So this is one type of barriers. This is in fact a hybrid barrier. There are simple barriers also can be there, but all these are designed with principles of mechanics. We have to calculate the potential energy from where the rock is coming down and the kinetic energy, and then what should be the energy absorption capacity of the barriers also. So for all these things, the calculations are there. Nowadays, good softwares are there, and the best part, my message as a person who is continuously working with the IRC, ISO, and BIS, we do have the Indian codes also. So I am skipping the last one in the series. It is the umbrella structure. Suddenly, at present, I am working in a project in Assam, and suddenly the cut slope, because they have cut the slopes in a very unengineered way. All the civil engineers witnessed it, but it is being done because the DPR consultant has designed without seeing the site. So once the slopes are cut, the landslides also started. But in those type of places, it's even risky to go near to that. So how can you do very quickly, how can you erect? So this is a system, this is a system which help to make a emergency protection system. So here you are combining a fascia and a nail both together. Like an umbrella, you can just open it and you can place it and fill the soil behind it, and that will become a system. And the same is being used for preventing the mitigating the avalanches near places like Kedarnath. So the last, I'm skipping some of the slides. Barrier detail, channel barriers. Again, if you want to know more details about rockfall mitigation measures as well as the barriers, the drapery systems, one can go to HRB 23. It's a state of art report. Now IRC has made a decision to make it as a guideline. So we are working on that. But HRB 23 is quite good enough for beginners to understand that what are the criterias, how the testing, what how one can select it, how it can be designed, and how it can be optimized. So the standards we were talking here for IS 160142018, that is for the Gabions, SP 116, that's design of Gabions, 113, it is flood disaster mitigation, IRC SP 102, it is for reinforced soil wall, then MORTH is covering geosynthetics in section 700, 3100 is covering reinforced soil structures, 2500 is covering Gabions, then IRCSP 48 is covering Hill Road Manual. So I have just means and say picked up some of the codes and guidelines. I can say that the last 20 years, all these advanced flexible materials are completely defined by its specifications, the design, the how to prepare the BOQs, how to calculate the forces which is coming on it, how we can make the quality conformity at site. All these are well explained in the codes and guidelines. I'm not going to the case references, but a lot of structures. So the company which I am working, McAfee itself, has done, I think, more than 3,000 structures or 3,000 projects we were involved. And it's not only McAfee, there are other geosynthetic companies are there, rockfall sector, there are good companies are working. So I will suggest always whenever I am addressing the group of academicians. So definitely the syllabus need to incorporate the knowledge on these type of structures also. So I have shared the selected slides to the organizers. I hope that you will be receiving um, the slides which are prepared for this course. And any doubt is there, please convey to me. My contact number and email ID is with the professor. Thank you. Any questions? I know the time is over, but any questions? Maybe one or two questions I can take.
Yes, Sharon, madam, participants, any doubts, please unmute, uh, then ask.
Yeah. I'm not sure how much time I was just talking and you are not hearing.
Actually, this is online FDP. Some people are maybe working whole day, and
Uh-huh.
from the workplace they are attending it. So they are very much exhausted and tired. So maybe they are not listening that efficiently. But I have some queries, madam, a
Yeah.
little, regarding that slope stability. Do you calculate any uh, rock parameters
No,
for
I didn't get you. For the slope stability, the you are asking about the parameters.
Regarding related to rock mechanics.
Yeah, see, the rock mechanics as well as the geology will come in the part that to decide that what may be the rock size, okay? Because the once the rock size is defined, then the people who are working on that may not require that. But the initial part is the one who is having the expertise in the rock mechanics, one who is having the expertise in geomorphological behavior, everything is required. Then only we will be able to really predict that what can be the rock size and from where the detachment point can happen. Okay, because those are important to assess what energy it will be having and whether your static forces will be the dominant or dynamic forces will be the dominant part. Yes, rock mechanics will come, but don't assume that means NSE, the person who may be finally talking to you about a rockfall barrier will be the rock mechanics person. May not be. He may be more the person who will be knowing about the barriers and its energy absorption capacity and all. So your question is very relevant for me because that is really prompting me to explain the fact I didn't tell. These type of systems will be requiring multiple specialities. Okay, so somebody who is able to coordinate the different type of specializations together should be there if we have to tailor the design. But definitely that is the place where the codes, guidelines, ready reckoners all are there. But for important projects and significant projects, the specialists should be involved from beginning to the end. It's like Mumbai Pune Expressway. So that time, really, we had to, even if we were having very good team in India, we had to bring one global specialist who maybe means and say number one or number two in the world, who can means really predict that what can happen 20 years or 30 years, because it's like within 3 months 40 crore had to be spent for the just drapery systems for from MSRDC. So definitely it is worthy to involve a specialized person and pay for him, okay, rather than throwing crores of rupees for without having the understanding. Yeah.
And other things is that we are doing some research related to waste material like red mud, flyers, iron ore tailings, those things. But I have a desire to do some research related to this rock thing, which you are actually dealing. So can you suggest some area where we can do some research where money or financial resource is not that needed?
Okay, maybe
Yes.
one area at present means NSE very recently it's developing, but still a lot of development is required is real time monitoring, because this digital monitoring
Yeah.
how the real warning can happen and in the right time, and especially if barriers and all are really not very cheap, right? And the maintenance need to be decided how frequently and all, and those will be placed in not in urban areas or anything. Some places like Kedarnath, Badrinath, and it's not where the pilgrims are going, may not be exactly, it will be at some height, so it will not be easily accessible. But then from a distance, the monitoring is possible. The movements can be measured. So that may be an area which can be really how that can be measured, or how the predicting no, it can be predicted, how the models can be developed. Maybe a very good area.
And I hope there are some software which you are dealing with maybe.
Yeah, yeah, yeah. Yes,
Can you give
series of
some
softwares. Okay,
link?
because it's otherwise even if a very experienced person also just we cannot throw the numbers. It requires repeated analysis and lot of probabilities. Like in the barriers and all, there can be n number of ways the rock can move. So we have to see the projectile motion, and we need to see the most critical motion, and the barrier has to be designed for that. And even for a drapery system, whenever we are going for short nails, long nails, and all, so for the analysis, if you do manually, it will take a lot of time. But software, with the help of software, you can do very fast.
Can you name some like Plug 3D or Fluxus 3D, that kind
Yeah,
of?
yeah. It's all, most of them are FEM based. I can share with you some generic softwares, and
Okay.
some of the softwares we are using, which is means and is a little customized for McAfee, because our material, the whole data we can put directly. For other materials, yes, we will means and say define everything. So, but number of generic popular softwares are there. I can give you a list. Definitely.
Please, ma'am, you give me.
Okay.
Actually, I asked Vaidam sir also yesterday, and he shared me the link and all. And I will
Yeah,
share
yeah,
if you participate. So
sure,
that
sure,
they can find some scope for using their research purpose or academic
sure,
purpose.
sure, sure, sure.
Yes,
Yeah,
ma'am.
that was a little unexpected question. I will think more about it, and I can share some of it. Definitely, this is a developing area because of the construction which is happening in our border areas, mountainous terrains, and a lot of slopes are cut without any sense, you know. So we create disaster prone areas every year, more and more getting created, and these type of protection systems are required. Okay.
And also, madam, these days artificial intelligence, AI, and machine learning, ML, so AI, ML, these things are like entering everywhere.
Yeah,
So in your area also, it's coming. How it is coming? Like it's getting incorporated in terms of what?
yeah.
So any idea you can explain? Application of AI ML in your field.
Sorry, can you repeat?
Application of AI ML, artificial
Huh.
intelligence and machine learning.
Yeah, yeah.
Is there any scope in your field?
Yeah,
Suppose.
yeah, exactly. I was talking about especially this monitoring part. So for the monitoring part, not only for the rockfall or anything, even for reinforced soil, for we are constructing very high structures, tall structures like 40-meter high, 90-meter high, like Kannur International Airport. We constructed a wall which is 87-meter high. So when you are constructing the reinforcement, we are really uh, predicting that this is the strain which can happen, and with that strain, this is the strength and all. But uh, definitely during the construction, a lot of things are changing. A lot of permutation combination will happen. Okay, so now the tools are getting developed. AI based tools are getting developed to see that the actual design and during construction, what are the variations which are happening. Okay, sometimes it may be means and see quite favorable, the variations what are happening. Sometimes it can, the cumulative variations can really kill the purpose of the structure, because we are assuming a lot of things in soil mechanics. We assume like it is plain strain condition, it's isotropic, it is homogeneous, but the cumulative actions will be really creating a huge error, and that may not be the, even the best software at present available also is not able to really quantify it. But the AI is really giving a hope, yes, that can be. So the hope is that the present research, the hope is that these type of errors and these type of uncertainties will get controlled once AI is means really becoming more active in the field. Yes.
Okay, ma'am. Thank you. Thank
Thank
you
you.
for this
Thank you for the platform.
very resourceful talk. Are there anyone who is asking any doubt? I listen like someone is asking question. Huh? So thank you, madam, for your resourceful
Thank
talk.
you.
And
Thank you
I'm
so much.
apologizing for that Jacob. I put that Jacob with your name. I got it
No
from,
problem.
I got it from LinkedIn.
No, no,
But,
no. My husband is telling his thanks to you because it is his name.
okay.
Okay. So I always carry my father's name, Korulla. So he is very happy and he told a special thanks to you. So,
Okay.
right,
And
but in the industry, I'm known as Minimol Korulla only. Nobody knows Minimol Korulla Jacob. Some LinkedIn it has come, so that is it. But all other people in my family is Jacob only. My son, my daughter, everyone is Jacob. Thank
I'm
you so much, sir.
observing that
Thank
pattern
you.
all the time. And in
Thank
your
you.
WhatsApp